back to our senior project design videos. In case you forgot, I'm Sam Heck.
I'm Peter Oliver.
And I'm Ryan Jones.
And if you haven't already seen it, please check out our first design video. This will introduce you to our project and what we will be talking about today.
In our last video, we showed you what we were going to build, and we covered some key vocabulary that you'll need to know.
Let's start with a little review.
If you recall, the system we are designing is modular. This means that it is broken into smaller systems.
Here you can see the 3D models for all three modules in our system: the power module, the water wheel module, and the entertainment module. Again, if this is new to you, feel free to watch the first video.
Today we're going to show you guys some of the work we have done to actually build our project.
We have been working for about 9 weeks and have accomplished a lot during this time.
We will start with the power module, the hardest part of the project.
The power module is the center of the whole system. Without it, nothing works.
The concept of this module is that when a motor is engaged, it generates electricity, which in turn powers the pump or the TV.
To engage the motor, we need to rotate the shaft that you can see here. To do this, we need to attach a large plastic wheel in such a way that when it was rotated, the shaft on the motor would spin.
The first step for this was to create a giant plastic wheel. For this, we used a machine called a mill.
A mill is a large machine that works like a drill that slowly chips away at whatever material you are working on. Here you can see a mill cutting a line through a piece of metal.
Here you can see how we use the mill to turn a square piece of plastic into a circle.
Notice the little flecks of plastic that fly off as the blade slowly chips away at the large square piece.
Once the plastic circle for the power module was complete, we attached it to the motor. Here, we ran into a problem.
When we turned the wheel, no matter how hard we tried, we couldn't get the wheel to spin fast enough to generate enough power. We needed a way to turn the wheel faster. Our solution to this problem was to insert a gear.
Gears are commonly used devices found in all sorts of everyday products. Gears are used in cars, bikes, clocks, and many other places.
When a large gear is used with a smaller gear, the large gear can be turned slowly and the smaller gear will turn really fast. As you can see, when we slowly turn the first gear, the second gear actually turns much faster.
This allows us to spin the motor faster without increasing the rate at which we turn the wheel on the power module.
Now putting the gear onto the motor was no easy task. We realized how strong you all are and that if we don't do this correctly, it could break.
We decided to weld the gear in such a way that no matter how hard you try, it won't break.
Welding is the process of heating up metal until it melts. Once it's melted, it will stick to other hot metals. It's like when it cools, it is as strong as one piece of metal.
Here is a video of Ryan welding the gear. Notice he has to protect his eyes from the bright light created when melting the metals.
And here's a picture of the power module with the plastic disc, gear, and motor. Although it still needs a frame, it is essentially complete.
With this complete, we turned our attention to the video game module.
The goal here was to take a game originally designed for one person and turn it into a game that takes 5.
Here you can see the original game we bought. It previously used a joystick as a controller.
Here you can see the game taken apart and in the process of being rewired.
And here you can see the completed version of the game with the 5 buttons rather than a joystick. Again, it still needs a frame, but it works and is complete for now.
The water wheel module is tricky because it requires a lot of plastic and must be watertight. This means that we have to cut our plastic to almost perfect dimensions.
To do this, we used a table saw.
A table saw is a table with a blade in the middle. This blade is used to make very precise, straight cuts.
We began the construction of this module by cutting all of our plastic pieces to the correct sizes.
Here you can see the plastic pieces we cut and are beginning to put together. That's a lot of plastic.
Once it is complete and the brown paper is removed, this module will look like a big ant farm.
With the plastic cut, it's time to construct the water wheel itself.
To do this, we use a 3D printer. A 3D printer is like a normal printer, but it uses hot plastic instead of ink. When this hot plastic cools, it sticks together to form one piece.
It deploys this plastic in long, spaghetti-like strands that layer over the top of each other to eventually create a whole part. Let's look at an example.
Let's say we want to 3D print this bridge. The first layer will come from left to right like this. The second layer will stack and begin to close off the top of the bridge. As each layer is added, we can see the bridge begin to form.
Now with the water wheel, it takes thousands of layers, but it is the same concept.
Here is a video of the water wheel being constructed. It is a slow and delicate process, but the results are very precise.
Let's speed this up a little. Notice how it started from the bottom and is adding thousands of layers to slowly increase the thickness.
Here is the completed water wheel.
With the water wheel complete, we have everything we need to finish up the construction of the modules and their framework.
In our next video, we will show you the completed modules and how they work. We will also conduct some testing to make sure that our finished product completes the requirements we showed you in video number 1.
Thanks, and we'll
See you next time.